All right, so here is where we kind of left off. We talked about all the different standard deviations for a population and for a sample. Recall that we used the lowercase sigma for standard deviation for population. We just use regular s, lowercase s, to represent the standard deviation of a sample. Big N was used for population to determine how many were in there. We used little n for the sample, but we subtracted it by 1 to keep the math relatively consistent, and somebody came up with that equation. Remember, variance is basically whatever the standard deviation is squared, or vice versa. Standard deviation is the square root of whatever the variance is. So sometimes, I don't know if it's on your homework, but sometimes it's given to you as, hey, if this is the standard deviation, what's the variance, or vice versa. So you don't have to go calculate. You just have to do some simple math. All right, but when we look at example 12 here, it says find the standard deviation for brand A. So we're going to find the sample standard deviation for brand A listed in 3.9, which is all right, there it is right there. That's not brand A. Is in example 310. Yeah. So example 310 has our brand A and B. All right, so it does give it. Oh, good. I don't even have to go find it. I didn't even realize they gave it to us. All right, so brand A is there. Recall that the sample mean for brand A was what? Can I get a confirmation on that? 35? 35? Okay. All right, so that was our sample mean, and you need that to do this. Remember, what does this symbol here mean? Good. That is the sample mean. And then X would be these guys. This would be your X, which is the actual whatever that uh, sample part is. So this right here would just be 10 minus 35, which is negative 35. I will, oh, you're right. Sorry, negative 25. You're right. Right. Hold on. I will say this. What is kind of nice is it doesn't matter about your negatives and positives, because on the very next one, you're going to square it. So when we square a number, what's our outcome always going to be? Positive. So if you're stressed about the negative and positive, it's not going to matter. Right. All right. And then if we go 60 minus 35, positive 25 this time. 50 minus 35, 15. 30 minus 35, 40 minus 35. Good. And then 20 minus 35. Negative 15. Good. So again, make sure you're taking the X value minus the mean. And now we're going to square this. Do you happen to know what 25 squared is? What, 25 times 25? Nope. Huh? Nope. That's 15. No, I don't even know what that is. If you don't know it, it is 625. I will say it's helpful to know your squares to at least 25, and up to 25s. Yeah. Yeah. You might want to expand that just in case you have to take college algebra, because you're not using a lot of calculator and they expect you to know that. Oh, yeah. I don't know. Now I know the formula that goes with it, and I would just add, um, what is it? If I want to know what 26 is, I would just add 26 to this number. I think that makes it. I don't know. Because what's 24 squared? It would be, I don't remember the formula. Something like that. It's like doubled, or I forget. All right. And then 25 squared again is 625. Do you happen to know what 15 squared is? Y'all said it earlier. 225. 5 squared is 25. 5 squared is 15 squared is. Very good. So again, notice no matter what, if I would have missed the negatives, it would have worked out for me at the end. And then now this little sigma here, that just means the sum of. So we're just going to add all of those numbers. Yep. So we're going to take 625 plus 625 plus 225 plus 25. Oh, plus 25 plus 225 is 1750. Yes, sir. All right. So now we've calculated our standard deviations numerator so that we now have the answer. It'll be the square root of 1,750 divided by n minus 1. How much of the samples in brand A do I have? 6. So this becomes 6 minus 1, which is what? 5. We're not there yet. We're getting there. So here is just n minus 1. How many there are minus 1? So there was 1, 2, 3. So the n technically here is 6. That's what's in our sample. So then it becomes 6 minus 1, which is 5. Now we're going to do the inside. What is 1750 divided by 5? 350. Right? And now, this is the part I don't know. So what's the square root of 350? I think it's control or second x squared, just like the Inspire is. Eh, good. And do remember, we want to go to one place value past where our stuff was. So since all these are in our ones, we're going to go to the tenths place. Had this been in tenths, then we'll go to the hundreds. Remember that last statement yesterday? Yes, that's fine. All righty. So any questions on how to calculate the standard deviation by hand? All right. Now you're saying that there's another equation that's being given to you in the homework, right? So let's use that formula so you understand it. I'm going to get rid of all this real quick. Does everyone have all this information they need? Good, because it just went away. So here's the formula y'all keep talking about. Or using the shortcut formula that does not use the mean of the sample. So what this means is, I don't know if this is really a shortcut or not, but what I can do is I can square all of my x's and add them up. Yeah. So let's work this all out. So my n here is 6. We got that. So I would need to square all these. So if we squared all these, let's do some side work here underneath it. What's 10 squared? 60 squared? 1,000. 3,600. 50 squared? 2,500. 30 squared? 900. Remember, it just has two zeros. You just have that two. Good. 1,600. And then 400. Very good. Let's add those up like it says. That number. So we get 9,100 minus now this is kind of different. You have to add them all up and then take that result and square it. So now it's going to be 10 plus 60 plus 50 plus 30 plus 40 plus why is it not even typing? I'm over here. I could have said something. That's it. No, I'm just over here just typing. Where am I at? 10, 60 plus 50 plus 30 plus 40 plus 20. So you take that right there, and then we need to square it. So we're going to take 210 times 210 and get 44,100. What was the question? Oh, and then on the bottom here, this would just be 6 times 5, because that's what n minus 1 is, because this is 6. 6 minus 1. So then we can do some more math. Oh, I really don't feel like this is a shortcut. All right, this would be then 6 times 9,100 minus 44,100. And so then I get 10,500 divided by 30. Then take that, divide that answer by 30. We get 350, which I'm pretty sure is what we got on the last one, right? And then if we just hit this little square root button, what happened to my stuff? There you go. All right, so then this ended up being 18.7. So we get the same answer. I don't know what seemed easier to y'all. So that one felt easier. The one above it that we did, but notice that both of them give you the same conclusion. I'm actually more familiar with this one than I am with this one. But this might be quicker if we got more in our sample space. It might just be easier to add them all up rather than subtract, then square, then divide. Or I really don't know. To me, I felt like I was doing just about the same amount of work. So, but that's your call. I'm not going to be specific on it. It does have this little TI-84 concept here. We'll use this concept to find um, we have Inspire. So go ahead and grab an Inspire because you'll be allowed to use these calculators, and I'll show you how you can do this using the handy dandy calculators. Thank you, Charlie. All right, so what you're gonna do, open up your calculator, go to list and spreadsheets. That's like the fourth app on the bottom. It looks like an Excel sheet. What we're gonna do is we're gonna use this to calculate brand B, which I don't know where that's at. Wasn't example 10? There it goes. All right. So what we're gonna do is you can name this whatever you want. You can call it B, whatever. I'm just gonna say brand B. You can't put any spaces in there when you do it, and then just hit enter to get out. Right now, we're going to leave this equal sign alone, and we're just going to type in our data. So this would have been 35, 45, 40. I don't know why I'm saying it like that. 35, 40, 25. You ever get those moments where you're like, you talk to your kid? Never mind, I don't have kids. So. Yeah. We're gonna do some trial and error because I want to say this will work. So what we got to do first is we need to calculate our differences. So what we're going to do here is we're going to take, it's already in the equal part. So we're just going to say this is going to be equal. And we're going to say A. And what it's going to do, it's going to take column A and we want to subtract it from the mean, which in this case is, what was it? What was brand B's mean? Do you remember? I feel like it was also 35. It's above or the enter or below the control or something. What we get? Yeah, remember? 30. I think it was 35 for both. All right, so we'll do 35, and when we hit enter, it calculates it for us. So you don't put the name that you put, you just put the column that you want it. So it took all of the A's and subtracted 35 from it. No, it does it naturally. So I just put a capital, or I don't even think I put a capital A. I think I just typed A and it did it. Well, I know, but I think I just typed A and it naturally made it a capital. So we did equal A minus 35. And it just did all that math for us just then. Anyone not getting that as their results? Okay. So now that we got that first column, now the next step was to square that. So now you're going to come over here to the next column. You can put equal to start equation. This is the same way as Excel. And I want to square all of my numbers in my B column. So I'm going to hit B and then hit the square button. So you get B squared there. And when you hit enter, it'll square all those numbers for you. So it did all that work for you. The next thing we did is found the sum of that. I wonder if we're able to. I wonder if I do something like this. Hold on, don't do this. Yeah, don't do that. That was wrong. Let's see. I just want to equal the sum. Let's see. Let's go to menu. Actions. What's actions? Data. Data capture. Clear data. Okay, what's that going to do for us? Okay, isn't that what I did? I want to do B. Wait, what happened to my C's? No. Oh, you said something? Oh, okay. I'm glad. I didn't hear it. All right, there it goes. Here, equal. I'm just going to type sum of C. 100, 150. That is right. Put it for all of them. I just wanted one. Um, Interesting. You just need to care about one, but we got the answer. So then what we want to do is we found the sum. Now we want to divide that number. It did it naturally. Oh no, no, I typed sum and then parentheses, yeah. And then I put the C in there. So we took that and then now we're going to take that result, divide it by n minus 1, which in this case is 5. We get 50. What'd you say? I wonder if there's an easier way. Go to the left. I wonder if I could have done it all at once. What if I did it all right here? So if that's the b squared, and then I took the sum, and then we divide it by 5. I do care, yes, sorry. And then now I just want to take the square root of that. So I wonder if I could just do square root. What is that? Control. There you go. And then we'll put in E. Yeah. Or you could have put 50. You should get the same result. There you go. All right. So there you go. And this is actually beneficial if we would have had like a lot of information to do. Right? Yeah. So any questions on how to use the calculator? You'll be allowed to use the calculator on the test. So there you go. Any questions? Excel is probably a lot easier. I'll show you Excel real quick, just in case you want to use Excel for your homework. Well, y'all have like Google Sheets or something. But if I wanted to, I could type in my data. I could say this is going to be brand B. What is going on here? Let's say this is brand B. And then if I wanted to, just to give you another idea, I don't remember brand B. Yeah, I don't know if y'all are going to have Excel. So I just want to, it's kind of similar. I mean, there's not too much different when it comes to these easy ones. So I'll just type it all in. And it's kind of the same process. I'll literally come over here, do equal. I want to take, and I'll choose this cell minus, what was that average? 35. And it'll calculate all of them for me, just like that. Then I can come over here and I can say, all right, I want to take this previous cell and I want to square it. So I'll do shift rooftop, which is a exponent, and then square, or the 2, and hit enter, and it'll do all of them for me, just like in the calculator. And then from here, I don't have to make more stuff. I can just come over here and say, all right, I want to equal the sum, and it'll assume, do you want these values? Just hit tab and it'll do it for you. And then we'll go right below it to find the standard. And I'll even right over here, I'll probably just say my standard deviation. I'll just do SD and I'll say, all right, equals. Now I can put my whole formula together. It was the square root. So I'll do SQRT. And it was the sum, correct? Yeah, the sum. So I'll just take this cell. I'll divide it by n minus 1, which in this case is 5. And you get that right there. So I like Excel. Excel is amazing. Now, granted, we did all this work for just 6 numbers. This is really impactful when you have 100 numbers, right? So you don't have to do all those calculations. I'm good with you definitely using the Nspires on the test. I don't know how I feel about this on the test for Excel because it's really hard to monitor y'all screens while y'all take it. But y'all could totally do this during y'all's homework as well if you want to. All right. Any questions on the different processes? All right. This is just using Excel to find standard deviation. I put SD, but I think they just use little s. Yes. Yeah, that's what we get in the calculator, 7.1, right? Because we're going to round to the 10th split since all our decimals were the same. Same concept here. This would be 7.1. Also, what's really cool, if you are not very good, so I was about to use a different word. If you're not very good at rounding, there's this little button right here that will shorten your decimals for you. And you can just go until you get to that one you want, and it'll round it for you. Just if you're not good at rounding. All right. So I got any questions on the technology stuff? All right. Technology, I think, is a little bit bigger in statistics than it is in like in college algebra. Um, but let's go back into the notes. And so we got all of our answers there. That's just those. We got 7.1 as our answer. So let's kind of answer these questions real quick. So 7.1. And it says, what does this indicate about the variation of the 2 brands? Okay. And which one was bigger? Okay. So an A's value was what? Let's compare them. 18. Okay. What you need to know about standard deviation is the smaller your standard deviation number is, the closer your data is. So the larger your standard deviation is, the more spread out your data. So what we can conclude here is that brand B's data is closer together than brand A. And you kind of saw that, right? We saw like 10, 60, then a whole bunch of other stuff. And you saw on brand B that all of its data was kind of closer together. So that's what you can kind of conclude here is that what they wrote here is both means were the same, but brand B's data is more consistent, meaning it's closer together. Now, again, we were just looking at 6 data values. We probably could have just made that assumption on our own. But when you have 100 on both sides, that might be a little bit harder to see. Questions on what standard deviation can do for us? Yes. It kind of tells us how our data is made up. So since our standard deviation is so small, that means most of our data is closer to the mean. Standard deviation being large means our data is further away from the mean. Go ahead. Yes. So like now that we have some data here, we didn't have data last time, but let's take this bell curve I tried to write last time. We have our mean of 35. For brand A, if I wanted to know where most of my data was, one standard deviation, so 1S, would be 18.7. Is that what you said? So that would be 35 plus 18.7. 35 plus 18 is 40, 53.7. And then over here, I've subtract that. 35 minus 18 is 16.3. And we can argue that like I think the number's like a 67 or I forget the numbers, but we can say that a certain percentage, if I could remember it. I want to look it up real quick. Yeah, you would add 18.7 and you would subtract 18.7. I'm probably getting way ahead of the lecture, but it's fine. 68.2. So I can say in brand A, 68.2% of my data will fall between 16.3 and 53.7. That's what standard deviation is telling me. And in brand B, it would just be, I would add 7.1. So in brand B, it would be 42.1 and 27.9. I can say that 68.2% of my data in brand B will fall between 27.9 and 42.1. Okay, so I am getting it. I was like, this connects somewhere. I just don't know when I connect it. Gotcha. But that's what standard deviation does for it. It tells us where's majority of my data. So the smaller it is, the closer my data is to the mean. Yeah. And the closer to zero, if you get like zero for your standard deviation, that means every number is the exact same. So if I have zero as my standard deviation, all of my numbers will be 35. So like I could tell you, hey, my mean is 35, my standard deviation is zero. What is my 10 data points? You're like, whoa, I don't know how to do that, but you do. They're all 35. Or it might say, hey, what's 68% of my data going to fall between? And you would say like 34, 36 or something like that. We'll get more in detail on that. I'm just getting way ahead. But that's what standard deviation does for us. That make more sense now? I know I got ahead of the story, but that is where we're at. All right, so you can see the sample standard deviation is S with a little x. If population is entered, it would be this. I'm almost positive it's a lowercase sigma and then the x. Right? But questions on notation. So remember, Greek letters go to population, non-Greek letters or Roman letters go to sample. But I just don't know what S is in Roman. Do y'all have? I know it like X, V, M, I, maybe. I don't know. I don't remember. I'm not very thorough in my math in the Roman language. All All right, uses of the standard deviation. This is probably going to say the same thing I just said. Who knows? But it says the standard deviation provides a, there we go. So it does. So it says the standard deviation provides a measure of spread of the data. Other words you might see is or variation. I think spread just sounds better. So it tells you the spread of your data. If the standard deviation is large, the data is more dispersed. It is used to compare the variability of two or more data sets. The standard deviation is used to determine the consistency of a variable's value. So if I wanted to know a certain variable where it falls in relation to the mean, if it is not between those two numbers I just wrote earlier, I could say it's outside of one standard deviation. Malachi. Oh, gotcha. I thought you're looking suspicious. All right. And then the standard deviation is used to find the number of data values that fall in a specific interval in a distribution, which is what I just said. And the standard deviation is used to infer statistics. So, like I said, the closer the number is, I can say more of my data is closer to the mean. Right? Further it is, there's definitely going to be some outliers as well. Any questions on standard deviation? Okay. So let's talk about the coefficients of variance now. Can you guess this blank? It is. It is. So coefficient of variance is a statistic that allows comparison of standard deviations of data sets having different units, such as a variable measure in inches and a variable measure in centimeters. So we can compare the two that way. The formula for the sample coefficient of variance, or also known as capital C, capital VAR, or CVAR, is expressed as a percentage. So we'll take whatever the sample standard deviation we get, divide it by its sample mean, so little s over x, times 100 to give us a percentage, right? That will kind of express our percentages to us. If it's population, same concept, just the different notation, little sigma, little mu, times 100. Right? I want to say mu is like the letter Z for us or something. Yeah. Any questions on formula there? Very straightforward. All right, so let's go to the range rule of thumb. All right, so a rough estimate of the standard deviation is just going to be the range divided by 4. If I just wanted just a rough guess, I could just calculate my range, which again is largest minus smallest, and then divide that result by 4, and it'll approximate that result. We can kind of quickly do that if we just wanted to look at brand A. We calculated that was 18.7. What is 60 minus 10? Divided by 4 would be what? I don't know. Let's look it up. 50 divided by 4 is about 12.5. So it's not close to 18.7, but we can kind of see that's our ref estimate. And then brand B, I think, was a little bit closer to its range. The range there, I think, was 20. So if we do 20 divided by 4, we get 5. So we might not get the exact numbers, but we can come up with the same conclusions that brand A will still be a little bit more spread out than brand B. Not always. Yeah, it's just going to be it's really rough. Yeah. It's just if you wanted to make some quick analysis or something like that. All right. I don't know how to say this guy's name. We'll do it together. Chebyshev. Chebyshevs. Cheb. I love Google. All right, but I want you to say it. So you can say it. No, it doesn't. Whatever. That guy's theorem. I couldn't find it. All right. So the standard deviation of a variable measured spread or dispersion of the variable. The larger the standard deviation, the greater the dispersion. The smaller the standard deviation, the less the data values are dispersed and the data values are more consistent. That guy's theorem finds the proportion of spread in terms of standard deviation. So the theorem applies to any distribution regardless of shape. Basically, some guy saw that on the standard deviation and made it his own, but it's basically what standard deviation is. Well, he saw it first. So he just made it his own. It's his theorem now. I'm I'm sure they're working on it, but it's not. There's probably new ways to do math, but there's no like new formulas that develop. All right, the population of values from a data set that fall within k standard deviations of the mean will be at least 1 minus 1 divided by k squared, where k is greater than or equal to 1 and not necessarily an integer. This just simply means that your standard deviation is going to be basically, it could be 0 through all the integer or all numbers. So I can have a 3.2 standard deviation. I could have a negative 4.8 standard deviation. All the things. Actually, sorry, I take that back. Take that back. This is stating that the standard deviation has to be positive. So if I subtract a fraction, the fraction will always be less than 1 or equal to 1. So it has to be, basically, you could almost say the standard deviation is 0 or greater than any number. Right? All right, so there we go. So hours online per day. So let's look at this example here on 13. It says Americans, do y'all have that in red? Huh? Oh, but y'all have it already? All right, so this one says hours online per day. Americans spend an average of 2.85 hours per day online. If the standard deviation is 32 minutes, we're going to find the range in which at least 75%, that is when k equals 2 standard deviations, and 88.9%, and that's where k equals 3 standard deviations of the data will lie. All right, so to do this, first change the average of the sum units as a standard deviation. So we are calculating hours to minutes, so we need to figure that out. I need to get down to our math here. Here we go. All right, so to do that, there's 60 minutes in an hour. So we're just going to take 2.875, multiply it by 60. And we get 171 minutes. All right, so we just got to turn our standard deviation or our mean into standard deviation units, so they're all the same. And then it says for 2 standard deviations, which is 0.75. They kind of did the math here. So that'd be 2 squared, which is 1/4, who's 3/4, who's 0.75. That's kind of how they did the math here to calculate what what the 2 standard deviations would be. And so to figure that out, you would have to add and subtract these values. So they did most of this work for you, but you got 2 times 32, because that was the standard deviation. This is standard deviation. So 2 times 32 is 64. Then you add the result and subtract the results to kind of determine where most of our data will be. So what's 171 plus 64? And then what is 171 minus 64? 107. So what this is stating is that 75% of my data will be between 107 minutes and 235 minutes. It does have it in hours. So we do some quick numbers here. We can do 235 divided by 60, and we see it's about 3.9 hours. You get 235? Oh, yeah, you're right. 235, yeah. So it would be, I looked at the wrong one again. So this would be 3.9. Do we have any decimals? What was our we had 2.85, so when you go to 3 decimals, so that'd be, yeah, so 3.17. And the reason I'm going to 3 because my original average or my mean was given to me as 2.85. So we always want to go one decimal further. So then the same concept, we'll take this and go 107 divided by 60, and you get 1.783. What was it? Yeah. Yeah. Questions on this? So again, this basically just states that 75% of people probably range between 1.783 hours to 3.917 hours online. Okay. Now, if we want 3 standard deviations, and again, they show the work again for you. So you can kind of see why the percentage is the way it is. There it is. All right, so for 3 standard deviations, so that would be 1 divided by 3 squared, is 1/9, which is 8/9. So that would tell you that 88.89% of this people online abilities will be between these two numbers. And so then they took the 3 multiplied by the standard deviation again. So S time or 3 times 32 gave us 96. So 171 plus 96 gives me 267, and 171 minus 96 gives me, oh, far off there. I did. He matched what the paper said. Yeah. All right, so then we can say that basically 89% of my of the population probably spends between 75 minutes and 267 minutes. Could you probably argue that 89% of everyone at least spends 75 minutes on a phone and probably not more than 267 minutes? I think that's possible because y'all get those little notifications on your phone and it tells you how screen time each day was. I get excited when I'm less than 2 hours. Oh, I feel like you might be an outlier. All right, so let's calculate what the hours are. So 267 divided by 60 is 4.45. All right, now watch what I'm about to do here. I'm going to go 4.450. Yes, one more time. Oh, I don't know. 75 divided by 60 is 1.25. 0. Yeah, if you're at 7 hours, I'm thinking you're an outlier. All right, but this might be statistics before cell phone. Oh, this is sorry, this is as of 2015. Technology's advanced since then, so these numbers are probably going to be a lot higher. All right, any questions then on how to calculate your range using standard deviation given to you? Okay. I'll take silence as golden. All right, so thus by this guy's theorem, at least 88.89 of the data is between. Oh, did I not fill that out in the other first two? Okay, sorry. Yeah, so on the 75, that was again 1.78. What was the 3 hours and 3.9 something hours, right? Whatever those decimals are. And the same concept here, this would be between 1.250 hours and 4.5 hours, 0 hours. All right. So if we look at example 14 now, it says average time to traverse a maze. So it says the average number of trials it took a sample of mice to learn to traverse a maze was 12. Um, so it took them 12 times to figure out a maze. You ever seen those little cheese things? Kind of cool. All right, the standard deviation was 3. So that just means that when we calculate it, 6 or 75 or whatever, 68, whatever the percentage is, would fall between 15 and 9 type thing, right? And that's what they're basically telling you to do here. And it says it wants you to use the theorem to find the minimum percentage of data values that fall between 4 and 20 trials. So they got a little equation here for you. You got 12, which is your mean, minus the standard deviation, which was 3. You don't know how many standard deviations away that is. So your standard deviation was 3, but you're trying to find out like how many standard deviations. Like if it's 3, like was it 1, 2, or 3 away? But you want to see from 4 to 20. So all you got to do is just solve for K. But do y'all understand how we get to this? Remember, the formula was the mean minus the standard deviation times whatever the K is. All right. This is the standard deviation. This is like basically the S that you calculate is like one standard deviation. But how many standard deviations was it? Yeah. Yep. Solve it like any other problem. So if I do this, what's the first thing I would do to solve? Minus the 12. So I get negative 3K equals what's 4 minus 12? Negative 8. Divide that by negative 3, and you get what? Just keep it as a fraction. 8/3. Or roughly 2.67. Right? So there's your K. So that means that 4 is going to be about, and I'm going to say since means here, I'm going to say that the 4 is going to be about 2.67 standard deviations away from the mean. All right. So in my eyes, that's going to be about, I think like 98% of your data or something like that. We'll go through the numbers though, but it's something like that. And then something like this, how do I solve this one? All right, so just so you know, the whole minus here is because this was the low side of it. Plus would be the high side. Because if I'm going to the left of the mean, I would be subtracting from it. If I'm going to the right of the mean, I'd be adding it. So here I would still subtract 12. So what is 20 minus 12? 8. And then if I divide that by 3, you can see that I'm still what? 8/3. So that means that my range from 4 to 20 is about 2.67 standard deviations on both sides. So again, I'm thinking about 98% of our data is going to be between there. But let's calculate because that's what's going to make us do next. Let's see if we're right. Questions on any of this math? All right. We're just so what we're doing is here is our data. So here's the thing, we don't have data, but we have the result. We're trying to infer from those results. So we know that our average is 12, and we now know that this 4 here falls about 8/3 of the standard deviation away. So which in more easier terms to see is about 2.67 standard deviations away from the mean. So we have like, this would have been 1 standard deviation. This would have been like 2 standard deviations. And then the 4 falls right outside that, but within the 3. And then the 20 would also be 2.67. And then we're trying to get to that percentage there. All right. So I will post a video for y'all. The finish 3.2, 3.3, and 3.4. Keep an eye on Remind. I'll let you know when I post it. Yes.